Okay, we are going to start 10.3 today. In 10.3, we will be using the area addition postulate. Which just says that the area of a figure is the sum of the areas of its non-overlapping parts. Okay, and today, besides using that postulate, we're going to be finding the area of composite figures. Composite figures are a figure with a complex shape that can be divided into simple shapes. And these simple shapes are the ones that are on your little note card with circle, rectangle, triangle, all those shapes, all those formulas we had earlier in the chapter. And your goal here is to try to get the fewest number of pieces. That just saves you work. Okay, so we just have examples, and I think you'll catch on pretty quickly. So our first example, straighten that out. Here's our shape. There, and then this. So here's what I've got. A 90-degree here, 32, 14, and 20. Now, if I asked you to find the fewest number of shapes you can see there, hopefully you come up with two shapes. I see up here a half of a circle. It's not a full circle. And then down here, a trapezoid. Maybe you might have wanted to chunk it up again and do rectangle, triangle, and half circle. That would work, but that's an extra piece you've got to work with the formula for. So the way I want you to do homework is to first, just with words or symbols, tell me the fewest number of shapes you see. So I see a half circle. And I'm going to add to that a trapezoid. So there it is in words. That's my plan. Now I want the formulas from your little note card that you have. I don't have mine here with me, so otherwise I'd show it. But a circle is pi r squared. And if I multiply it by a half, that will cut that area in half because I only have half a circle. So 1/2, and then it's pi r squared. A trapezoid, if you look on your card, you're going to add the bases together, times by the height of the trapezoid, and then divide by 2. Formula, very simple if you take the time to do these steps. Now it's, look, here's the circle up here. All I need to know is the radius. Well, if you look, the top of this trapezoid, this base on the trapezoid, is the diameter of the circle. That means the radius is going to be 10. So 1/2 pi 10 squared. Now the trapezoid is all I'm looking at. The bases are the parallel sides. That's the 32 and the 20. The height of the trapezoid is how far apart those are. That means a 90-degree angle. It's right here. They are 14 apart. And divide by 2. And picking up a calculator, I've already done these. 157. 0.08. Over here, 364. Adding them together, 521.08. Okay, so find the pieces, write in the formulas, rank it out. Number 2. Shape looks like this. We're going to start with big isosceles triangle. And we're going to attach on this lovely shape. We've got this parallel to this. And this side parallel to this side, giving us a nice parallelogram there. In terms of dimensions, I've got 10 here. 3 here. 8 here. And 6 here. And 90-degree there, and a 5 here. Okay, so let's talk about the area of this total figure. Again, I see 2 pieces is the least I can do. I see this big isosceles triangle, and then I see this parallelogram. So my composite shape is triangle plus parallelogram. If you look on your card, area of a triangle, base times height divided by 2. Parallelogram is base and height. Now, don't think these 2 b values are the same and these 2 h values are the same. We'll be looking at different parts of the figure, so those do not match. So make sure when we do the triangle, you're only looking at the triangle. So triangle is down here. I see I've got an 8, a 10, and a 3. I don't need all that. I need base and height. Oh, I need this here though, 90-degree angle. So there's my height, there's my base. So it's 10 times 3 divided by 2. The parallelogram, again, base and height make a right angle. I've got a 6, I've got a 5, and I've got this 8 that could go over here if I needed it. And a 6 over here. So base and height make the right angle. So the 2 numbers I want to use are the 8 and 5. The 6 is there just to bother you. So base 8, height 5. That's the hard part. Now, a calculator if you need it, but that's 30 divided by 2 for a 15. That's 40. Total 55 square units. I didn't put square units back here either. Okay, moving on to something slightly different, but not a big quantum leap. Number 3. Still a composite figure. This is what it looks like. Oh. This is going to be a 90 here. Didn't quite make it look like it. Then what I have is a big chunk missing. Let me take a bite out of this triangle. So this is technically a void in it. It's missing. So I want you to be able to find the area of everything around it. And let's see, I've got 18, 26, and a distance from here to here of 6. So our plan here will not involve adding. I think the easiest way to do this one, I see the full triangle with this bite missing. It's been taken away. That tells me to subtract. And what shape has been taken away is a half a circle. So our plan with symbols is to find the area of a triangle. Then instead of adding, we're going to subtract because this is missing from the shaded area a half a circle. Now, formulas. Triangle, I don't even care about this right now. It's just base times height divided by 2. 1/2, because it's a half a circle, not a full circle, pi r squared. So now I'm ready to look at the shapes. The triangle, base and height, right angle is right here. So that means I'm going to use the 18 and the 26. Divide by 2, and then we're going to subtract off 1/2 of a full circle. The radius, I need the radius from the center out. Well, if you look, I've given you the diameter is 6, so each side is 3 and 3 and 3. So you can see the radius is 3. Finishing this off, calculating this with a calculator, you'll get 234. Over here, 14.14. Subtracting leaves a final area of 219.86. We're going to keep going, practice some more. Number 4. We are going to go with this. Here's my center. And this, and our goal is to find the area outside of that shape. All of these pieces added together, what will that total be? Okay, so here's what I have. I have a 10 here, which is the radius, from the center over. I've got a 12 across the top. I've got a top to bottom of 8. All right, so it's all about the plan. What shapes do you see, and should we be adding or subtracting? Well, I see the biggest shape there is that full circle, but now the shaded area is missing this big white voided piece here. And that, if you look at it, is a good old trapezoid. So our plan to find the composite area is find the area of the full circle. Then we will subtract off this shape here that's missing. That shape is a trapezoid. Once you've got the symbols down, go to your card, grab some formulas. That's pi r squared. This is base 1 plus base 2 times height divided by 2. Now the hard part's done. Go to the pictures, grab what you need. So we've got pi, circle, radius, center out is right here. That is 10. The bases on the trapezoid, well, all the way across here, didn't really give it to you, but you can get it by just adding 2 10s together and getting 20 across there and given 12 across there. So bases are 20 and 12. The height is how far apart those bases are. Perpendicular distance would be 8. Divide by 2 and make sure you're subtracting. So we will have 314.16. Subtract, cranking through that, 128. Subtracting leaves 186.16. And let's do one more to get a shape we haven't had yet today. Number 5. Oh, let's push that out of the way. I can use this piece of paper here. Example 5. Here's our shape. Yes. Think of those as 12 o'clock, 3 o'clock, 6 o'clock, 9 o'clock. Connect them. Okay, and our goal is to find this total area here. Okay. So before I even put any numbers in, I'm going to come up with my plan. Again, I see a full circle with this big piece missing in the middle. And because I put those evenly spaced, those are all going to be congruent. So our plan here is going to be to take the area of a full circle and then subtract off this shape in the middle here. Well, this shape in the middle, because it has 4 tick marks on it, would be a rhombus. Formulas first, pi r squared. You might have to look this one up. Rhombus is diagonal 1 times diagonal 2 cut in half. So now I'm going to give you some values. I'm going to give you one number. The distance across the circle, or the diameter of it, is 6. So that's enough for me to get the area of a circle. That's all I've got to do is cut that 6 in half to see that the radius is 3. Diagonal, well, diagonal given as 6. The other one's going to cut through the center and be another diameter. So both diagonals are going to be 6 because they're both diameters of the circle. That's pretty simple. So we've got 9 times pi is 28.27. 36 cut in half is 18. Final area, 10.27 square units. So that finishes that. On the homework, I do want to see the plan with words, the formulas, then your numbers. So you will be showing work. And that is all.